All right, we're live. Excuse me. Tonight's stream is going to be about my restoration of a Digital Equipment Corporation LK201BA. This is the case for it. And I just did a print last night, my biggest one and longest one. It was 9.5 hours. You can see all the supports back here for this little section of vertical plate. Did it 5 millimeters thick, and I'm going to be talking about that and what I did and why. This was just the first one, and it's bad, but it was just to get started and see how long it, basically first foray. So we're gonna do a better one. The point of tonight is to get a better one set up, queued up, and I'll do it overnight tonight. So I just want to show you some of the steps of what I do. So right now I'm going to take these supports off. I have safety goggles on, and I'm using my gloves because the smaller prints I did, they dry very well. This is the first one that is still was basically the result of sticky resin, and I don't quite know why, other than I left it too long, I guess, before taking it off the print bed once it was done. But just trying to learn more about how my printer works and how I'm going to use it. I'm going to get to this more later, but my eyes have really opened up once I've had this printer. It makes me think a lot differently about projects I could do with it, because it's kind of mind-boggling how much it opens up. Like the fact that I can 3D model anything and print a prototype until I get it right, and then maybe ship it off for something that's the real deal or more expensive. Not quite sure how to get rid of all these supports. I suppose I could also try breaking them, but they're not breaking, they're pretty rubbery. I read one interesting thing about a person that puts them in a kind of a hot water bath and then they come off very easily. That was intriguing, but we won't be trying that right now. But let's see if we can cut through some of these up here. Basically just trying to free our 5mm acrylic plate part. There's layers all the way through here, but maybe I can peel them back a layer at a time. So I just cut the top and bottom, so now I can get rid of that. These are the support structures. The other question I keep forgetting the answer to, and I should start memorizing, is when I have a part like this that's vertical, can I print it vertically? I don't think so. I think these holes won't show up, so I think you have to tilt it and use support structures, but I'm not quite sure. I need to revisit that, but let's just keep breaking all this stuff here. That one's connected to the next layer, so. Not very organized, can't really see it that well, so I'm just clipping whatever I can find as far in as I can find it. Let's go back up top and try to get the next layer apart here. It's interesting because they're right up against the back of the hole that's in the front. I guess that's on purpose. How they line that up. Getting this line will be done this row, so we kill the top part there, and then maybe we can peel it back. Wow, this is some messy stuff. As you can see here, I'm now using wax paper because the sticky resin, I looked up what does resin not stick to, and so wax paper was one of the comments, and as well as other things like a plastic baggie, like sandwich bag, What else? Rubber, vinyl. Let's see. Still think encroach or cream the top is going to help us here. Never had a couple problems with this that I've never had, like one that came out so sticky and one that has so much structure. This was the biggest build I've done. It filled the whole thing, but I'm gonna do it differently next time. Get a better. Actually, while we're talking about it, so I kind of cut too wide of a piece and stuff, so it couldn't fit this way. So next time I'm gonna go narrower so that it fits this way. And then I'll angle it towards the long end of the bed. So I should, right now this one was intended to go, from the bottom of the keyboard to the top, but it didn't fit this direction. But if I make it narrower and turn it long ways, then I believe I can get off the bottom and off the top on both ends. So that's what I'm trying to do tonight. But this part's a little more tedious than I thought it was going to be, but I'll just hang in there until we can get it all broken out of there. Kind of don't like the mess of this resin stuff. I just like to do a good job sweeping it up later, but what else we got here? So that part feels pretty good. I guess it's this is stuck here. There's a decent chunk. Now I get it. Like basically right near where they connect, the support structures go up, but then at the very end where they connect, they're the thinnest. And so I should be looking at this like horizontally like this and trying to go in at this angle flat to shave off the narrowest part of those connections. So that part's looking pretty good. Lower here. See if I can do this without breaking off my actual part that I printed. Breaking it in half, but I guess I could also try up in the bottom here. That's not going too good. How about back to this again? Okay. There's some more. We're getting there. They're still attached. Okay, I think we're getting down to the last layer here. Let's see if I can break these guys off. Okay, now we're down to this last bottom layer, I think. Okay, quite the mess, I would say. Let's see if I can clean this up a tad. We can move on to different parts of this project here. But this was an exercise that was, I kind of wanted to show. See if you have a better experience or you're able to cut it faster, cleaner. Like I said, that was the biggest part I've ever done, so it took a while and it was messy. I'll have to think about how to make it easier. And yeah, things like the guy was mentioning where a water bath makes the structures, a hot water bath makes the structures more pliable and come off easier. That might be worth investigating. So I'm going to clean this up a little bit more. So I'm not going to sand it or anything, but I am going to just give it a little once over. Make sure we get all the structures off of all the support structures off. Okay. I did 5mm thick, and so you can see that this was, I think it's overkill too much, but it probably actually helped us from breaking this thing apart. It's pretty sturdy, solid piece. Looks more recognizable now, doesn't it? Without all that support structure behind it. You can see what I was going for there. Okay, I'm actually going to take my clothes off now. Probably shouldn't be handling this resin too much, but geez, messy. Okay, let's get on with this, shall we? Take off the safety glasses. Where's the bag? Okay, so I have a lot. I kind of want to revisit and tell you guys my journey so far about 3D modeling. Here's the thing I just printed is actually this. This program is Fusion 360 Autodesk. We'll talk more about that in a second. Let me switch to let's see. What was I going to switch to? I was going to talk about Mesh Mixer, I guess, real quick. What I used to do was, when I first started this, and I wanted to, basically for this DEC terminal, it had yucky plunger membrane stuff, but everything else about the keyboard I liked a lot, like the keycaps and double shot with some blue and some are red and some are black and some are white. So 4 different kinds of double shot. And the case is kind of, the shape is cool, but case itself is yellow, and probably I might try Cerakoting or something, or retrofitting, but regardless, my goal is to kind of try to attempt to do to mod it to Cherry MX, whatever it takes. And so I started with Let me get the Finder window up actually. So you can see that when I started, I stumbled on Mesh Mixer and I found it pretty easy to learn, or for the most part. And but I ended up doing 11 revisions on the keycap stems and things. And so actually, if I bring up Mesh Mixer, we can kind of probably look at that a little better. If I took like, I don't know, what was I doing? This is revision 1, and I probably didn't even know what I was doing, but the mix file is like probably a 2D thing. See, let's look at this cap base cylinder. I drag this into here. Oh, you can kind of see. Let's see, you know, you can see that this might be a keycap stem replacement that would be in the keycap as a new Cherry MX mount. So that's an example of what I was talking about, but suffice it to say that I ended up printing for 2 weeks straight with a bunch of resolutions, and every time I try to change some dimensions, and let's see, let's look at this one, negative cross. Now let's see something. I'm going to try to pick one that's cap base. I need to widen this. Oh, I'm on the wrong screen. No, I'm on the right screen. But why can't I? There we go. Yeah, cap base 650 negative. So this, my numbering scheme was 600 is really 6 millimeters because I needed to get down to 3 digits of millimeter resolution. So this is 6 millimeters circular, you know, diameter of the circle, and then 5.6 millimeters as, no, okay, hold on. 5.6 millimeters diameter, and then maybe 6 millimeters tall. And then the hollow out part in the middle is 1.15 millimeters. These are like the arm widths. So one of the arms is 1.15 millimeter. So let's just take this file in here and you'll see what I'm talking about. But,
it's super stinky in here. I know.
Let's see. Here's, so we'll load this up, and I was trying to do things like, you know, denote on it what the sizes were, because once you print these out, you're like, what the heck was this one that I like so much? Because they all just look like a mess of little parts when you get, after you print them. So this is obviously a close-up view of what I modeled as my keycap stem. And but the problem I had is next time I wanted to go change this, one of the dimensions, like to change maybe this arms, how long it is across, or, you know, all that kind of stuff, I'd have to go back to 2D, rechange the dimension, and then rebuild up the 3D solid. And so trial by fire, that's actually probably a decent way to learn, because then I realized what I was missing, and the answer is called parametric modeling, so that you can have a solid that's in 3D, but it's based on numbers that when you change them, the solid knows how to, is constrained appropriately to grow the way you want it to, and retain all that stuff, so you don't have to go back to the base and rebuild it. It just knows. And so that's, you know, there's a lot. I mean, I guess traditional CAD/CAM would probably has always done that. I don't know, but I realized I was missing it. I found what I was missing, and I chose to use Autodesk's Fusion 360. If you haven't heard of that, I guess when I'm an old digger, and so when I was growing up, it was you know, CAD/CAM, I was like, that's complicated, I don't know how to do that. But then now here I find myself wanting it and needing it for my keyboard hobby, and the Mesh Mixer was a nice kind of warm up couple weeks, and now the terms and the familiarity and everything's similar. You just have to learn the Fusion 360 way of doing things, and so it was harder to get into, but having that base in Mesh Mixer was helpful. So I'm really excited because, like I said, the combination of me well, let me describe a little bit more, tiny bit about what I think Fusion 360 is. It is actually the AutoCAD program, but it has some differences, and what's different is, okay, AutoCAD was probably this legacy code base that had command line interface and maybe more CAM oriented, but the newer one, the Fusion, in my opinion, involves, like, it's a cloud, for sure. It's got cloud based, so all your saving and collaborating of files and this and that is all done in the cloud instead of local. It doesn't have a command line interface, I don't think, and it also, embraces this new world where not everything's like exactly this dimension and round and circular and triangular. It's more like the free form stuff. Like for example, if you can take 360 imaging around with your iPhone or something around some real life object and get a mesh out of that and import that and play with it. Mesh Mixer for sure can do that, but I think Fusion 360 adds that kind of mesh-like capability stuff to melds it with the existing CAD more strict measurement stuff. So that's my take on what Fusion 360 is about. I think it's amazing, everything I've seen so far. It's a wonderful product, super powerful, more than I'll ever probably learn. Tons of great videos and training. Lars Christensen, I like almost every talk I've heard of him. He's a pleasant speaker to listen to, and he's informative, and I've been able to find so much stuff and revisit it through him, and yeah, so I think it's definitely helping my journey. So now let's see. So Mesh Mixer was like this, and I always had to build it up from 2D every time I want to change measurement. But now in the modern setup, let me show you a little bit of the cloud stuff. This actually, I can have all my projects. So like I have a keycap one and a plates one. It's all under my mechanical keyboard team, I guess, or whatever. And then in the keycap one, I have this particular keycap stem mod that I'm doing for my DEC LK201BA. But I think lots of this will be reusable, but part of it involves a jig. So like this is the, is this closing this help, I guess? Let me see if I remember let's see. Yeah, this is how you spin it in 3D. So this jig is meant to be on the top of an upside down, it's also upside down itself. I'll try to show you more in real life in a second, but this is something I modeled. This shows how it was sort of built, I first built the base, and then it's kind of a lot to go into, but basically you start with a 2D sketch, and then you usually extrude or project it into 3D, and so the more things you nail down in 2D definitely helps later when you do the 3D. One quick thing I'll show you is like, here's the parametric based stuff. Like these are things that where's my, this was not on your screen, but let me bring it over there. Yeah, this is the kind of stuff where, let me see if I can get the units wider here. The stuff that matters, like a keycap is 18 by 18 millimeters, and the stem width is 5.6 millimeters, and the cross arms are this long, and this width. So that's a little hint at what's going on with the parametrics, so that, I guess the proof's in the pudding. So let me show you, actually, I'll come back and I'll show you, well, no, let's do it now, I guess. Okay, so if I go back to the end here, where am I suppose, okay, so am I back at the outer guy? Okay, so the proof in the pudding is if I go change like the dimensions of one of the keycap, let's say width or whatever, and change that to 30 instead of 18, we should see that we're now, instead of 18 by 18, we are 30 by 18, yet everything else maintained. It's nothing's out of whack. Like I can print this and make an extra one, actually, yeah, like something like a 2U keycap, where I want to put the stem in there or something. So again, that's super cool, super powerful. Let me see if I can undo that. What is it? I guess that's not part of the, it's only controlled here, so I have to change my 18. But you can kind of, things you care about the most, you can set them in here, and if you did it right, it'll adapt. Okay, that's the jig. This is the stem that we saw before, and that's sort of, I'm going to close this. No, I don't want to save because I was just messing around with the sizes. And then this is and once I got done with those two enough, like basically I moved those from Mesh Mixer to Fusion 360, so I'm happy that I was able to build those up in Fusion 360. I'm super excited that they have the parameters they need to just dynamically change the 3D model whenever I need to or want to. And now I'm moving on to like the plate. I want to you know, I had shipped off a plate to get it. I'll show you how I arrived at a plate in a minute. But right now, I just wanted to show you that this part right here is what I printed, and I want to back up through the timeline. By the way, the history and the timeline is you can do a lot. It's very powerful with this tool, but you could see if we back up let's see if I can cursor through it. I don't know. No. So, so basically, I'll try to zoom out here. I thought we'd see some better stuff. Oh, stuff's not turned on? No, it should be turned on. Yeah, so we got kind of, I put this box represents the build volume of my Elegoo Mars MSLA printer. It's a resin printer with fine resolution. And so I was just kind of making these boxes, and putting them over the top of this keyboard that I imported. So I think this earliest one will be that keyboard. So hold on, I'll let this render. And I think we'll see the plate that I brought into, actually maybe I have to go back one more, but assuming I didn't crash it, but you can kind of see the bodies over here. So I was basically taking the print volume and using the sidewall, plane of it to cut through the plate, the keyboard plate that I had extruded, that I had imported, and I'll show you where it came from. And I'll show you why I'm planning on making my own as well. But, well, I can hear things churning, and my fan's getting hot in my MacBook, so I kind of want to kill that. Let's see. I'm going to kill Mesh Mixer. I'm done talking about that. I do want to kill this, but let's see if I can use the old-fashioned force quit, because I don't like what it's doing right now, and then actually haven't had it happen. But it's locking me out right now, but let's try to ignore that, I guess. Let's go back to OBS and let's flip over to my iPhone. So I just showed you this part. If you want to see what the other parts look like, they basically look like this. Here's I showed them before, I think. So this is the jig. This is what a new keycap modded stem would look like, turning X mount. And so it obviously would fit on the jigs. I can prove it. Okay, so this is the keycap stem on the jig, and then the point would be, let's see if I got a keycap over here. Like this is a keycap, but it still has a stem in it. But if you took that, I carved that stem, I broke them off actually from my DEC LK. And so this jig is holding the new keycap stem that I want to go in there. So if I suspend it down in there, then I can squirt glue in there until it hardens and then remove the jig. That's my idea. So that's why I built these two things first. I think it's pretty far along, and I was like actually getting ready to really go for it with my keycaps, but then I learned that I'm using prototyping resin, and it has different traits than, you should probably buy different resins if you want some better traits. And so there's one, Soraya Blue, I guess it's an engineering type resin that's harder, and lasts, because it's hard. So I want to use that. Then the problem with that is it's finicky with temperature, so you have to have a, like 78 degrees, and then my Elegoo Mars printer, my room, it's subject to my room. My room isn't that warm, so basically you have to make a temperature sensor that can maintain that temperature to get good builds out. If you don't, the builds fail. This is what I'm reading, so I believe what I'm reading, and so I guess I'm trying to find or build a temperature sensor that I can put in my Mars Elegoo. I did order the new resin, so basically I was in a hurry to get my keycaps done, but then I realized I shouldn't be in that much of a hurry, and I should get the right resin and make it work right. So I switched to the plate project. So actually, let me grab a steel plate so you can get what it is. This this is a standard one that I printed for some other projects. I have this project of this case that has the Delphi logo on it, so I don't really know, but I like the case, and it's pretty standard layout, as you can see. So so this gets to how I got this is similar. It's the same thing. So let me show you that real quick. Let's see if we can kill Fusion or not. Oh, there you can see the plate. So let me show you that real quick since it came back. So that's the plate, and I don't know if it's extruded or not, but I just want to be done and not risk the session in here with geez, where's the, give me a second. Okay, here it is. Oops. I want to quit this. And then we'll talk about how we got that far. So, okay. Bye-bye Fusion 360, hurry up, thank you. So it all started, I watched a video, I should give the guy tribute, but I don't have his name handy, but I think he's a New Zealander or Australian guy, but Board Talk or one of those kind of things. But anyways, stumbled on this, keyboard layout editor. I think this is quite amazing. Props to the guy that made this. You can add keys, you can you basically drag them around to where you want them to go, so you can make whatever layout you want, and then and you can color things and color the key or the words on the key cap, all the stuff, man. It's just super amazing. Then I think maybe why was so that people could use it as a rendering thing, and then maybe put it as your signature when you're on GeekHack or this or that. But basically this is a very helpful tool because you can get out of it the raw data, which is JSON that describes like kind of the layout. And then this guy, who's also very awesome, Will, made Swill KB, and it's basically a CAD system that, but you take your layout and paste it right in here, that one I just showed you, like this one, and then say what kind of plate you want to make, like is it for an MX or an this one's, I guess, straight MX. This one's an MX that you can take the top housing of the switch off. If it's soldered below, you can still take it off and lube it, the springs and whatnot. Or you can do Alps or you can do both, So for simplicity, I chose MX, cherry only, and then, these are more for cases, but if you just do none, you're getting a plate. And so basically I said you do draw my CAD, okay, so then, whoops, I didn't put anything in there, so this should give us an error, but I can show you how this works. It's this easy. So once you lay that thing out, if I can copy this, and I paste it over here, oh crap, I did not do the right button there, swirl. Yeah, let's see if we can get back in here and do this right. What happened? Didn't copy right? So here's the raw data, and copy, and here we'll do our paste. That should get it in there. Now, the magic of this guy's app, which is phenomenal, is it makes one of these. And then I actually use this, and I said order from Laserdisc or Gist, and I actually would say Gist, and then basically that, oops, shoot, give me a sec. That, I was like, first of all, I was like, are they still around? Did they just take my money? I didn't get any feedback from them, but then, and I actually emailed them after like a month saying, is this getting made or not? And then all of a sudden it showed up on my door, and I was like, well, I had like an address of Russia or something, so whatever, it worked. And so I was super stoked, but then when I went and put this in my Delphi case, the problem is it's too wide right here. That's literally the next step I got to do with this is cut that off. So I did one, in one of my videos, I tried to Dremel this, but I actually ordered I got a new table, little 18 inch by 18 inch saw that goes on a table. It's called a Rockwell Blade Runner 2, I believe, and so I'll probably be using that to cut this. And from there, let's see, basically I was like, that's, I don't want to pay $35 in metal every time and try to get my sizes exactly right. And so when I got my Mars Elegoo printer, then I'm like, man, I can print these parts in resin and then adjust them and get them just right. Then I can ship off for the metal plate and it'll be perfect and it'll be done. So this is the start of that, and it was just my poor first attempt. Like I said, it doesn't even cover the whole. These are like the function keys up here, and then but it's cutting off. It didn't barely get. I guess it. Well, these happen to. This is the big space bar, and this is the little shift key. I guess so these are like where the stabilizers go and stuff. So that's. I guess it's sort of below that and just above that, but I can get more height out of it if I rotate it and make it narrower so it'll fit in my print bed. I'll be doing that next, and I'll probably try to shrink from 5mm to thinner ones and see how thin I can get without breaking. But let me tell you okay, so I have some more crazy ideas. Like that Swill KB that you saw, he just took the keyboard layout and he transformed it into what that would be to machine a plate. But in Fusion 360, I just watched a video from the guy about patterning. And so basically I can take this pattern and I can say replicate it across, you can replicate in all the dimensions. So I'm saying you can fairly easily do your own layout in Fusion 360. Like if I have the shape of this cutout, I can tell it how to repeat and how to stagger the next row and repeat. And so probably I'll make an alpha layout sort of that's close, and then I don't know, maybe like copy and paste the remaining few, and maybe, you can imagine each row having its own already laid out to start, and then maybe move stuff from there. But so this keyboard has a very unique problem. I don't know, I guess I haven't dealt with a lot of them, but these Digital Equipment Corporation keycaps are, instead of being like 18 by 18mm, they're actually 19.7 in the vertical dimension. So talk about annoying. That's why this jig will work, because I can make a jig that surrounds that measurement, and it will be centered over the keycap, and that appears to be what they did. And but you can see the problems that would cause with the standard layout. Like I can't use Keyboard Layout Editor through Swill KB because that's not gonna. I might be able to, but it's likely that extra 1.7mm is non-standard and won't adapt to. At least because those keycaps are longer, they're not going to fit in the standard size. They actually are going to be further apart, and the rows are. And so this tonight's actually about kind of trying to, I'm not going to dial that, I don't think we'll have time to dial that in. I'll probably but we'll see how far we get. So if we look at this, like I could use this or I could use this to kind of compare, but a couple things that are weird is these are sort of 0.75 height. Oh, you can't see it. Sorry, I'm going to bring it in. So, on this keyboard, all these function keys, they're very thin. I guguess I could get them out. They're in the other room, but these are 1 unit wide and 18mm wide and pretty standard, except for their height is all 19.7. Up here, these are 0.75 instead of 1U. So, but their width is still 18, but their height is actually so where these are longer than 18, these are 15 millimeters instead of 18.6 or something. So there's so many. Now I barely even started talking about this because there's so much to deal with. So like one cool thing is, yes, this switch fits in here completely, so that's a good thing. These had the longest stems on them that you could ever imagine, plungers that go into this that touch the membrane or whatever. So, but if it was the most over-engineered keyboard I've ever seen almost. So, but one interesting thing is, it had so many pieces parts. So there's tons of these little guys. They're those strange little plastic guys, and so what's interesting though is their feet go in these holes on this plate. So let me talk about what I would have done, okay? The concept here is, I guess, I don't know what I'm doing. I posted on Authority and no one really chimed in, so I didn't use the right wording or something. But I guess I was trying to say, how do I make convert the guts of an old keyboard to be Cherry Max, especially if it's an old rubber dome or something that's a horrible current switch is something you'd never use, but you like everything else. So in my mind, you got to start with the plate and you got to mount it to the top half of the case. And so that's where I was starting with this stuff. And so I was gonna maybe do that with this digital one. And then I've also had discussions maybe with like DMA and others about, I have a Silicon Graphics one that's a rubber dome that's curved, and that gives some beauty to it, but that exacerbates your problems with like making PCBs and stuff. So maybe I can hand wire. By the way, I haven't done any of this. I'm just heading down this path, and we'll see how far I get. But so I don't know yet whether I'll make PCBs for this particular project or I'll be doing hand wiring. But I'll cover some of that when I cover this stuff here. So I claim that I can measure, because these are consistent and this plate is consistent, this gap that's between these two, each row of these, is likely that extra 1.7 millimeter, or I can measure from the center of this stem to the center of a stem in this row, or basically trying to get that offset and reprove it, or line it up with this and say, how far off are these guys? Can you see the problem in here without even, yeah, I mean, so for example, actually, if I don't know, you get the gist of this, and I don't know, I guess I can put them back on there later if we want, but let's take it off for now. And like, look at this line is pretty straight, but like let's say I put the two holes, you're probably not seeing what I'm seeing, but the two holes of here, and then they just don't repeat all the way down, they get off as you go, but I don't have a good way to show it, I guess, on the camera. I'm doing my best here, but we'll see. But the other wrinkle is this keyboard, it also is not straight, but you can see it has bends like for the rows, because that plastic dimension is not gonna, so each row is fixed plastic, and so that's not gonna change. So they decided to put the bends at each row. Now, one of the revelations I had since getting my printer is I don't have to bend metal yet, or maybe ever, because I can print. I should be able to model this in Fusion and get those exact bends and stuff. I think I can do that fairly easily. So you can see it kind of goes down, and then it starts ramping back up, and then really steep, and then the plateau is where those function keys are. So I got to thinking, so instead of, well, my traditional thought, which would be, oh, let me just make a flat plate and bolt it onto the top, and then this case, for example, here's the top, and I think it's probably like this curve and this curve are morphing to that bottom plate. But let's say I don't use their bottom plate and I want to have something stick to a flat plate stick to the top of this, then I would probably be carving these out and making it flat so that I can keep as much room as possible by getting it as close to the top as I can. So that's the kind of project I'd be doing if I was trying to do a flat plate. But what I recently got intrigued with is the fact that my printer could print first of all, I know my printer can do these curved and strange surfaces, but it's like, okay, what about this bottom plate do I want to use? Well, since I can also print the resin and plastic, I could also, I'm thinking right now that I might do something with little feet that reuse these plate holes that line stuff up for me. But instead of whatever's up here with this stuff or even this flat top, I'll make it, I'll be putting basically these switch holes on that, on the plastic. Now we're talking, because then, yeah, so I got to figure out some heights and stuff, but I'm kind of thinking it'd be cool to reuse this plate's holes and how much height this uses. I think I could hand wire, like if I have just bottoms and switches poking out here, I think there's plenty of room in there to just hand wire it once I make I could make, this might be a unique project where I just make, instead of even shipping off for a plate or PCB, this is my this is my plate, rows of these, just like the ones they had there that were doing that. So that's where I think I'm gonna head. If I do that, I don't even need to measure, you know, what I was talking about here, like getting that offset right. But yeah, I didn't think about that. So I'm at a crossroads, but I think it was worth discussing because. Oh, by the way, what I was gonna do, you know, my print volume is roughly this size, you know, so you can imagine, I guess you print 1, 2, 3, 4, 5, maybe 6 of these, and somehow get some good glue bonding and glue it together, and there's your plate, right? So if I was gonna do a plate, I think I could do it with my resin printer, and I think it would work. But that's another experiment that I haven't done. So long story short, at the end of the night, I thought I was gonna maybe want to do another print with this narrower and turn more sideways, but with the right gap between it. But after talking this through, I think I'm leaning more towards, I'm gonna try to make this part and figure out in 3D modeling how to get something with rails with these feet that can go in and be stable, and with holes, you know, with the Cherry MX switch holes at the top instead of whatever's on the top of this thing. So that's what I think I'm going to do. So I think we'll be done for tonight. But I hope it was an interesting story. I guess we didn't do much but talk about my ideas. But just wanted to give a status on kind of what I'm thinking, what I'm trying to do, how I think I'm going to do it. As you can see, it morphs all the time. And even tonight, it just morphed into something that I didn't realize I wanted. And so, but I think it has promise. So you can imagine imagine it, right? Like, these holes are perfect. I print 3D rows just like this, except with Cherry MX. Put my switches in, put my stems in the keycaps with the mod, and then all that's left after that is wiring underneath and I guess a USB out with a controller in there somewhere. All of it is stuff I'm interested in and want to try, and to me that's the path that looks the coolest. You know, it looks like, oh, why not leverage these holes in this nice plate? Everything should match, right? If I'll kind of just have to get the heights right that the new switches will be in, but then I think the caps will be spaced enough apart just because of where these holes are. Wow, I think it's actually a good idea. So that's it for tonight, and thanks for watching.